Ikinagagala ko kayong makita sa araw na ito.
Ngayon ay magkakaroon na naman tayo ng panibagong leksyon. Ano kaya ito? Ito ay tungkol sa tautology and contradiction. Kapag nagustuhan niyo naman ang tutorial na ito, i-click ang like and subscribe to my channel. Huwag kalimutan na i-click ang notification bell para makatanggap ng mga panibago pang tutorial videos. Bago tayo magsimula, kumanta muna tayo. Mag-enjoy kayong lahat dito. Ano pang hinihintay nyo? Tara na at matuto na tayo.
When we talk about tautology, the truth value for a proposition is always true.
Say for example, if you will say a dog is a mammal, it is always true because all dog breeds like German Shepherd, Bulldog, Labrador Retriever, Chihuahua, or even French Bulldog are all mammals.
So, the statement is a tautology. The only condition required for a valid argument is to be a true statement. So in our example, we need to determine whether its proposition is a tautology or not. We have P or not P. Since we have only one variable P, so the outcome is only two, either true or false. In the first column, true and false are just the possible outcome of having P as the statement. In the second column, we need to get its negation or not P. So if we have true, the negation is false. If we have false, the negation is true. However, if we are going to look at P or not P, if there is true between the two, the result is true. Therefore, in the first column, we have true, false. The result is true. In the second column, we have false, true. The result is true. So, true or not false is true. False or not true is true. The proposition P or not P is a tautology. So, we have now the second example in B. Not P or Q implies R, and not Q implies P and not R. So, in order to construct the truth table, we will look at first on the variables used. So, in this example, we have P, Q, and R. We have three variables. So, you will raise 2 to the power of 3 to get the number of rows that you will consider in your truth table. So 2 to the power of 3 or 2 raised to the power of 3 is 2 times 2 times 2, that is 8. Therefore, in our table, you can see that there are 8 rows involved. Since we have 8 rows, we will divide it into 2. 4 of that will be true and 4 of that will be false. In variable Q, since we have 4 as true, we will divide it into 2. So, we have 2 of that as true and 2 of that as false. In the 5th to 8th row, we have false in P. We will divide it into 2 so that there will be 2 that are true and 2 that are false. In the third variable R, since we have 2 true and false in each, in the second column, we will divide it into 2 so that in variable R, we have alternate true, false, true, false, true, false, and true, false. So in the fifth column, we have P or Q. How to know if it's true or false? If there is true in the 2, the answer is true. However, if there is no true in the 2, then the answer is false. So in our fifth column, true or true is true. In the first till in the sixth row, we can see that there is true. So, it is automatic in column 5 that the answer is true. However, in the last two rows, you can see in P and Q as all false. Therefore, in the fifth column, F or F means F, and F or F means F. So there are two false in the seventh and eighth row. Then, after that, we need to see if what's the answer in P or Q implies R. So to know if P or Q implies R is either true or false, we need to consider that if the arrangement is true, false, then it is false. However, if it's not true, false, then the answer is true. Say for example, in the fifth column, we have T in P or Q implies T. So, it means true. In the second row, T or F means F, since it is only false when true is followed by F. So as you can see, in the second, fourth, and sixth row, the answer is F. In the fourth column, we need to get the negation of that in P or Q implies R. So, it is clear that the negation of T is F, F is T, T is F, and so on. After that, we need to interpret the answer in the negation to not Q. So, we will get first the not Q by looking at the second column. So, the negation of true is false, the negation of true is false, the negation of false is true, and so on. That's how to get the eighth column. After that, we need to compare the negation in the fourth column and not Q. So the answer is F and F is F. If there is F, then F. However, if there is no F, like in the fourth column, the answer is true. Do you get it? I hope so. So let's move on P and not R. We'll start first at the column not R. So we have R here in the third column. To get a negation, the negation of T is just F, F is just T, T is just F, and so on. After that, we need to get P and not R. So is it true or false? So in the last two columns, if there is true, then it's true. However, the two are the same, it is still true. So if there is true, then true. If the two are false or true, then it is also true. So we have here this one. In the ninth column, we have all results to true, since in the first row, we have false and false. The two are the same, so it's true. In the second, the two are the same, so it's still true. In the third, same, so true. However, here below, we have T, F. If there is true, then it is also true. Therefore, the result here shows that all are true. Then the proposition not P or Q implies R and not Q implies P and not R is a tautology, since the results are all true. So here are some common tautologies that you need to know. We have the following simple implications or simple conditions. We have first is the modus ponens, the process of affirming the antecedent. We have P implies Q and P implies Q. The second one is modus tollens, the process of denying the consequent. So we have P or Q and not Q implies not P. The third one is denial of a disjunction. We have P or Q and not P implies Q. Fourth one is simplification. We have P and Q implies P. The fifth one is adjunction. We have P and Q implies P and Q. The sixth one is hypothetical syllogism. We have P implies Q and Q implies R implies P implies R. The seventh one is absurdity. P implies Q and not Q implies not P. And the last one is addition. We have P implies P or Q. So these are some common tautologies that we need to consider in affirming or denying statements or arguments. Aside from that, we also have equivalence implications or equivalence conditions. The first one is very common, the idempotent law. We have from the first one here, P and P, if and only if P, that means P or P, if and only if P, that is idempotent law. The second is double negation. So, P if and only if the negation of not P. The third one is communicative law. We have P and Q if and only if Q and P. That means P or Q if and only if Q or P. So the two are just the same. The fourth one is associative law. We have P and Q and R if and only if P and Q and R. Or P or Q or R if and only if P or Q or R. Number 5 is distributive laws. We have P and Q or R if and only if P or Q and P or R. Or in other words, if P or Q and R, if and only if P and Q or P and R. The sixth one is contraposition. P implies Q if and only if not Q implies not P. The seventh is De Morgan's law. The negation of P and Q if and only if not P or not Q. Or we also have the negation of P or Q if and only if not P and not Q. The eighth one is equivalence for implication and dysfunction. P implies Q if and only if not P implies not Q. The ninth one is negation for implication. The negation of P implies Q if and only if P and not Q. And the last one is biconditional sentences. We have P if and only if Q, if and only if P implies Q and Q implies P. Or we also have P if and only if Q, if and only if P and Q, or not P and not Q. So that's how to read the symbols. And this refers to equivalence implications. So next we have some examples. The first one is P and not Q and P. So to simplify a statement means to express it in a simpler equivalent statement by applying established tautologies like this. In letter A, we have P and not Q and P. This means if and only if P and not Q and P. This is through associative law. The parentheses will be placed first in the second. This also means that this is if and only if not Q and P and P. That is through commutative law. So as you can see, we just interchange P and not Q here. We write first not Q and P, then it's followed by same not and P. This also means if and only if not Q and P through associative law. So we just group the second and the third through parentheses here. So that's associative law. The last one is if and only if not Q and P. Since by idempotent law, P and P is just P. So, it is now not Q and P by idempotent law. In the second example, we have not P and not Q and R. So from here, through De Morgan's law, this means not P and not Q or not R. From the second given, through De Morgan's law, we just distribute the negation in the first and the second term. So the first is through parentheses, and in the second, we have also the negation by just changing from and to or by De Morgan's law. This is if and only if not P or the negation of not Q or not R. So this means that we distribute the negation in the first and in the second term. So as you can see, we have not P or the negation of not Q, but then from and it becomes or. And copy the last. That is through De Morgan's law. After this, it is written as not P or Q or not R. So from here, the negation of not Q is just simply Q, and then copy the last. That is double negation. So if it is not Q, then the negation of that is Q, double negation. In the last row, we have not P or Q or not R. So we just eliminated
The braces.
as well as the brackets. To get this one, that is through associative law. Also, we have contradiction. We have definition of terms. The first one is contradiction. So you learned a while ago that if the statements are all true, it means tautology. However, if the statements or truth values of propositions are all false, it means contradiction. So here we also have the meaning of argument. It is an assertion that a given set of statements called premises results in another statement called conclusion. So from a premise, we can have conclusion, that's argument. In deductive argument, wherein the truth of the conclusion is a logical consequence of the premise, that is deductive argument. However, if the truth of the conclusion is supported by the premise, that is inductive argument.
Alam kong marami kayong natutunan sa tutorial na ito. Maraming salamat sa pakikinig at paalam hanggang sa susunod.